Welcome back to Environmental Economics for the fourth lecture in this series. Today we will look into the valuation of nature and payment for ecosystem services. This map of birds is designed by Luke Seitz. In the first lecture we reviewed different notions of scarcity, including the idea that prices may signal relative scarcity. Yet, in the second lecture, we saw reasons why prices sometimes fail to provide useful signals about value, where I focused on externalities. We only touched on another market failure that often applies to nature services, the issue of public goods. Public goods and services are those where consumption is both non-excludable and non-rival. Many of nature services have such a public goods characteristic. Non-rivalrous consumption refers to consumption by one not decreasing consumption possibilities for others. That is, my value from recreation in a national park is unlikely to decrease the value of such consumption possibilities for others. The non-excludability of consumption complicates sales or contribution. In either case, the value of public goods are not possible to obtain from market prices. The lecture reviews methods that attempt to obtain monetary estimates for the value of nature. What one considers as values of nature is of course highly subjective. One could wonder whether estimates of benefits from nature services based on objective measures can ever truly capture all nature's value. But as pointed out by Costanza and colleagues, although ecosystem valuation is certainly difficult and fraught with uncertainties, one choice we do not have is whether or not to do it. Rather, the decisions we make as a society about ecosystems imply valuations. We can choose to make these valuations explicit or not. But as long as we are forced to make choices, we are going through the process of valuation. Well, much of today's lecture will cover different quantitative methods like Hotelink's travel cost method and contingent valuation. Unavoidably, a review on the value of nature is also partially qualitative. It seems good practice in qualitative work to give some insight into the mind of the author, and I find that it can oftentimes be helpful to attempt to see the world through the eyes of others. And in this context, let me address some disappointment with the lack of questions that I expressed at the end of last lecture. It was not my place and could be a signal that the lecture still needs work. In any case, I realize that it takes time to process information and formulate questions. I do, however, want to emphasize once more that your questions are most welcome and will likely co-benefit your peers. Chapter 4. The Benefits of a Beaver. The only true voyage, the only fountain of youth, it would not be to go and see new landscapes, but in having others' eyes, of 100 others, to see the 100 universes that each of them sees, that each of them is. From The Prisoner by Marcel Proust. In Spanish, I've heard the phrase cada cabeza es un mundo, or every head is a world. Welcome to my world. As mentioned in an earlier lecture, this summer I went to Prague for the European Congress of Conservation Biology. At the Congress, I met Piotr Skorka from the Polish Academy of Sciences. Together with colleagues, Skorka demonstrated that the invasive alien goldenrods negatively affected grassbirds and wild pollinator communities in southern Poland. Alien species refer to species outside of their native habitat range, and these species are considered invasive when they are able to establish in the new habitat on their own and their spread is accompanied by damage to ecosystems or human production. Goldenrods are native to North America and a popular garden plant in Europe and Asia. Skorka and colleagues estimated that at least 7% of butterflies in Krakow end up as roadkill, and that Macaullinea butterflies, or large blues, would benefit from landscape corridors since a distance of 100 meters between isolated populations can already prevent much intersite mobility. The scarce large blue, one of the species studied, illustrates the many relations and dependencies between species. As larvae, scarce large blues first depend on a single species of plants for food, the great burnet, and afterwards they move into ant nests to predate on brood. Butterflies are just one example of possibly 10,000 myrmecophiles, or lovers of ants. Ants' nests can host specialized beetles, hoverflies, and tree hoppers. In this sense, ants, like us and beavers, can be considered ecosystem engineers. Upon hearing that I'm an economist, Skorka wanted to hear my opinion on what he called the beaver problem. He told me that he had once been involved in a valuation question that concerned beaver conservation. In short, a local government had concerns over the number of beavers settling in their administration. They were able to perform some calculations over the expected costs in terms of lost trees, river flow and land, but they had trouble forming an expected benefit side of the equation to help determine acceptable conservation efforts. Then Skorka paused and asked, how would you determine the benefits of a beaver?